Let's go over 5.7 notes. This is integrals of inverse trig functions. Let's review and recall the trig derivative rules. Now, trig derivative rules are trig inverse derivative rules. We know that inverse sine or arcsine's derivative is u prime over square root of 1 minus u squared. The derivative for arctangent is u prime over 1 plus u squared. And the derivative for arcsecant is u prime over the absolute value of u times the square root of u squared minus 1. Okay. And if you can, if you remember these rules, then it should help in knowing that your integral rules are basically just going to be going the opposite direction from these from these derivative rules back to the original function. So with some exceptions here, with the constant being changed a little bit, but we're going to see some similar patterns. So the first rule is du over square root of a squared minus u squared is equal to arcsine of u over a plus c. And the a is a constant value. So when you're looking at a problem, you can tell which is the a value and which is the u value. Your u value will be in terms of a variable, most of the time the x, and the a value will be in terms of will be a constant value. Now, if you compare this with the derivative sine rule, arcsine rule, you see similarities, right? You see the square root of 1 minus u squared. You see the square root, you see the u value, and the a value it's now a squared instead of 1. Okay, if you look at arctangent, the integral of du over a squared plus u squared is 1 over a arctangent of u over a plus c. There's some similarities here as well. There's no square roots for arctangent. That kind of makes it stand out a little bit, allows us to identify the rule a little bit faster. For arcsecant, du over u over square root of u squared minus u squared minus a squared is equal to 1 over a arcsecant of absolute value of u over a plus c. And we see similarities with the derivative rule for arcsecant. So let's look at example 1. The integral of 5 over x times the square root of x squared minus 9. If we think about the previous rules available to us, we can't use power rule. Use substitution. If we think ahead, that's not going to cancel out with anything up top if we let the u value be x squared minus 9. So we're going to try and match it up with one of these arc-trig rules. Now this is going to match the arcsecant rule. So we're going to, there's not going to be any need for u substitution. And we see that we see the x out represented by the u value here, the square root of u squared. That matches up with the x squared, and then the a squared is the 9. So we can still go through u substitution, but we're not going to see any there's not going to be any coefficients that's going to come out of it. So we're going to, let's match this integral rule with or this integral problem with the rule. And what you want to do is you want to get the exponents to show up. If you get the exponents to show up, then you know that your u value is going to be the base and the a value will be the base of the constant. So we're going to, x squared is already squared, the exponent is already there as a 2. We should need to rewrite 9. So 9, we want it to match the rule here. So we'll rewrite 9 as 3 squared. So we can identify that as the a value, and we can identify the u value as just x. So we can jump directly into our integral rule. 5 is the coefficient, I pull that out, times 1 over 3, because that's my a value, 1 over 3, arcsecant of the absolute value of u, and then that's just going to be x, over a, so over 3 plus c. So 5/3 arcsecant of the absolute value of x over 3 plus c. Okay, let's look at example 2. 1 over 4 plus parentheses x minus 1 quantity squared dx. We see that this, if we try to match it up with one of the rules, we see it matches the arctangent rule. So we know that this is associated with the a value because that's a constant. We see the variable here, so we know that has to be associated with the u value. And again, this matches the arctangent rule because we don't see any square roots. So we want to try and match it up the best we can with the format that we see in our integral rule. So I want the exponent to show up, so I'm going to have the parentheses squared, and the second portion can just be x minus 1, unchanged here. But the 4, I need to rewrite the 4 as something to the second power. So 4 is simply 2 squared. So I have my a value being 2, what's inside the parentheses. I have my u value being x minus 1, what's inside the parentheses. So a is 2, u is x minus 1. We find the derivative, which is 1. And dx is equal to du. We make our substitutions. Integral of 1 du. dx gets replaced with du. A gets, we have the a representing the 2. We have the u value representing the x minus 1. Everything matches our integral rule for arctangent, so we can go ahead and apply the rule. So the rule says 1 over a arctangent of u over a plus c. And finally, we can replace our a value with 2 and our u value with x minus 1. Okay, example 3. 1 over the square root of 7 minus 16x squared. And if you look, we see the square root here. We see the constant followed by the variable. So we see constant followed by the variable, and that's going to match up. And we see the square root, so we know that's going to match up with the Arcsine rule. So we want to try and match everything that we see with the rule on the left side. Okay. So in order to do that, we need the denominator to have exponent of 2. So I first have the square root, parentheses to the second power, and then parentheses to the second power. Now we need to adapt this so that this is the same as something to the second power. So 7 is same thing as square root of 7 squared, right? Square root of 7 squared is equal to 7. We haven't changed the value. We've just put it in a different form so that we can match it with the rule that's provided for us. 16x squared, we want this to be represented as parentheses to the second power. So we're going to put 4x inside because we know 4x quantity squared is equal to 16x squared. Okay. So when we do that, we can identify the a value and u value a lot better, a lot easier. So the a value is simply what's inside the parentheses. So a is square root of 7. Our u value is simply what's inside the parentheses. So 4x. We find the derivative for 4x, which is 4. Solve for dx, which is du over 4. And we make our substitutions. Dx gets replaced with du over 4. And we have our a value, we have our u value. Now if you look, we have everything set up just like the rule on the left side for the Arcsine rule. So we can now find apply the rule on the right side. So pull the 1/4 out in front. And the rule is simply 1 over a arcsine of u over a plus c. So our, I'm sorry, not 1 over a. There's no 1 over a for arcsine. We just have to keep the coefficient because there's a 1/4 there. Okay. So our simply arcsine of u over a plus c. So our u value is 4x, and our a value is square root of 7 plus c. And here we have our integral for example 3.